All right, we are in there. Let's get live on YouTube. Oh, it's already live. With the wrong title. Hold on. It is not Wednesday the 2nd of December. Monday. Oh, it's definitely Monday. 4th of January. Save. Cool. All right. It says I have excellent connection. I don't know if I believe it, but I have it. So, all right. All right, tell him I'm live now, or at least I should be. Yeah, I think so. Yeah, looks like it. So, same channel, new stream. Too late. I'm already set up. Let's widen this. Yeah, because I lean more that way. All right. Can you hear me? Am I coming through okay? Properties. I don't even know if it's using the right mic. That's not. No, that's right. I think that's right. Check. Whoops. Cool. Yeah, I'm streaming off my laptop. All right. Cool. We good? Can you see me on YouTube? Hello? Okay, cool. All right. That'll work then. I have no idea, but the streaming computer just decided to not. All right. All right, Christian, let's go and get started.
Okay, peace out, man.
All right, we're in Algebra 2. We're on Chapter 4. I do not have chat up. Actually, I can fix that real quick. I can fix that. There, now I have chat up. All right, so, cool. You can see me. I'm hoping you can hear me okay and everything. Yeah, here we go. All right, so we're on 4.1, page 154. Just streaming off my laptop, so sorry if the webcam angle ain't great and all that good stuff, because it's literally the one built into my computer. All right, so what are you going to do? Two variable linear equations, just fancy term for the equations we're used to, where y equals mx plus b or something along those lines. Real quick, with this, our Cartesian plane is split up. You know what's really helpful is if I do that. There we go. All right, so it's split up into 4 quadrants. Of course, the origin is at the center. And then, as we come around, okay, so first of all, this is the quadrant 1. Whoops, apparently I'm on a different color pen, but all right. So this is quadrant 1, where both values are positive. Over here is quadrant 2, and we work our way around to quadrant 3 and quadrant 4. And those represent the xy values. Again, this should be largely review, but let's go ahead and get into this from here then. All right, so as we look at this, our distance formula is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And so if I'm given 2 points like I am here in example A of -1, 5 and 3, 2, then what we're going to do here is we're going to get set up to be, or to use this formula. So the second x value is 3, and then the first x value is -1. So notice I'm going to put minus -1. All right, and this is, of course, going to be squared. Yes, I have parentheses inside parentheses. It's perfectly fine. All right, then I'm going to have y2, which is 2, minus y1, which is 5, squared. And then we go through and start solving like this. So d is equal to the square root of 3 plus 1 squared plus 2 minus 5 squared. Again, we're on page 154. Actually, I think we're on 155 now. Okay, 154 and 155. And as we get into this then, we can continue by solving. D is equal to the square root of 4 squared plus -3 squared. So we're going to have the square root of 16 plus 9. Well, 16 plus 9 is 25. So the square root of 25 then is 5, and that is the distance between those 2 points. Okay? And so that's really what we have here. That's what we're looking at. That's, again, your distance formula. with that. Why did I suddenly lose my screen? Oh, this computer got bored, which is how I'm actually able to see a screen too. All right. I know what, this is probably streaming at 1082 because, yeah, I just have it on my laptop. Anyway, moving on. All right, then we have the midpoint. Okay, I'm going to actually try to make this window a little bit bigger. Oh, right, so I can see better. Because I'm actually able to write on the stream itself so I can see what I'm doing. All right, so we have a midpoint formula. Okay, so your midpoint formula is equal to, we have x1 plus x2 over 2, and y1 plus y2 over 2. Essentially what we're doing is we're averaging our x values, averaging our y values. That'll be the midpoint of this particular thing. All right, so, okay, just making sure. Anyway, so with that, we can plug in two values and find the exact middle point between them. And so we have example B, where we're told to find the midpoint between 8, negative 10, and 6, negative 2. All right, so we have M is equal, and we have a formula above, but we would normally write it down. X1 is 8 plus X2, which is 6. And we're going to divide that by 2. And then we're going to have Y1, which is negative 10, plus Y2, which is negative 2, all over 2. And we can solve within there. So 8 and 6 is 14. So we have 14 over 2. And then we're going to have negative 10 minus 2, which is negative 12 over 2. So my midpoint is going to be 7, negative 6. Okay, that would be the midpoint between these two values. I know I'm kind of going through quickly, but again, a lot of this should be review, and we did lose quite a bit of class time due to technical difficulties. So hopefully this is making sense, but we're going to move right on to slope. Okay, so the previous one, just real quick, again, this is distance, then we have midpoint, and now we're going to talk about slope. Keep in mind, by the way, midpoint is capital M, slope is lowercase m. And so slope is equal to, remember, rise over run, or the change in y over the change in x. And the way we write that is y2 minus y1 over x2 minus x1. Okay? And so we have that scenario here. So then we're going to find the slope through the given points. I'm only going to do part A, but even though the book has several more. But this is example C, part A. And we have negative 2, 0, and 0, 2. I will briefly mention the others real quick, but I want to go through this real fast here. So we have M is equal to y2, which is 2, minus y1, which is 0, over x2, which is 0, minus x1, which is negative 2. Okay, notice the negative of negative equals positive, so I get 2 over 2, which is simply 1. So that's our slope. Our slope is 1 in this case. Okay. With that being said, if you look at part B, you'll notice we get negative 2 out of that. With part C, we get 0. If you get 0, remember that's a horizontal line. That's what that means. If there's no slope, you're not going up or down. When you're walking around on a flat surface, you consider that to have no slope. And then if you end up trying to divide by 0, well, of course, that's undefined. We can have 0 on top of a fraction. That's not a problem. It just means we have 0. If you have 0 halves, you have 0. But if you try to divide by 0, it makes no sense. Okay, so if I have 3 divided by 0, well, that's going to be undefined, as in example D, and that means we have a vertical line. It means there is no slope. It's not slanted at all. It's literally a straight vertical line. It's not no slope because it's a horizontal line. It's infinite slope, if you will, although technically that's not how any of this works. All right, so it's undefined. That's how we say that there. As far as numbering points go, one of the main things I do is I always take them in order. So I always take the first point as point 1, the second point as point 2. That just helps me keep it consistent across all my problems. Technically, it doesn't matter as long as you're consistent within the problem, but just kind of as a thing that I do to help make sure that things make sense. That's really the thing there. So one more example here, and then I'll turn you guys loose. Example D, we have -1, 1, and 0, -1. And again, we're told to find the slope. So slope is equal to y2, which is -1, minus y1, over x2 minus x1. Whoops, this is minus a -1. All right, so we have -2 over +1, or simply -2. Okay, so that's how we find slope. You can see there in your textbook on page 157 that there are 4 key slopes. Positive slope means that as you're moving across the graph from left to right, the line will increase. It will, let me get this right for camera. You will go this way. I think that, nope, it's mirroring me. Wait, no, that's right. Okay, I'm going to do it this way. If you have a positive slope, it should move upward as you move from left to right. It should move downward from left to right if you have a negative slope. Again, horizontal is 0, and then undefined is vertical. All right, so that gives you your examples. Your homework tonight is to do practice 4.1 green problems. Practice 4.1 green problems. That assignment is already on Google Classroom for you. Please make sure that gets done and in on time. Distance learners, if you have any questions, please feel free to email or text me, and I will see you guys later. And then hopefully I'll figure out what's going on with this computer and we can go back to normal. All right, I will see you all later. Have a good day.